This is the volume quiz review for the volume quiz. And we have talked about that any time we have a volume question, we should always write that volume equals length times width times height. This will prevent any problems that we may have. So the length we see is 6 inches, the width is 4 inches, and the height is 3 inches. And when we multiply that all together, we get 6 times 4 is 24 inches, and we're cubed at that point times 3, and we have to keep going. And then 24 times 3, we end up with 72 inches cubed. And we have to make sure that we have inches cubed. If we don't have inches cubed down, then we're going to lose points on it. And I'm going to circle that so the teacher can find my answer. So once again, we have another volume question, and it's volume equals length times width times height. And we have 13 feet times 20 feet times 6 feet. We always have our units going. And we start with our 13 times 20. And when we do 13 times 20, we have 260 feet squared times 6 feet. And then when we multiply that part out, we end up with 1,560 feet cubed, because now we have 3 feet times feet times feet. And we circle our answer to make sure that our teacher sees which one it is. Next, the volume of the figure pictured below. This is irregular here. It's not a perfect rectangle, so we have to just count. 1, 2, 3, 4, 5, and we have 5 centimeters cubed. That's our unit. Now we're over here. It is regular, so this time we say volume equals length times width times height. And when we do that, we fill it in. We have our length right here, which is 3. And then we multiply it times our width, which goes back, which is 2. And our height, which is up and down, which is 2. And we end up with 6 times 2. And we have 12 centimeters cubed. Next, it says to find the volume and show how you found it. So you must show your equation, otherwise you don't get full credit. So we have volume equals length times width times height. First we have our length of 3, our width of 2, and now our height of 2. And when we do that, we end up with a volume of 12 centimeters cubed. Next question. Once again, we're calculating the volume, so we always write volume equals length times width times height. Our length going across is 2. Our width going back is 2. And our height up and down right here is 4. And when we do that, we end up with 16 centimeters cubed. Always making sure that we are cubing our work. Next question. It says a rectangular prison has a top face with an area of 45 feet squared and a height of 9 feet. What is the volume of this rectangular prism? Show your work. So we have our volume is length times width times height. What we know and can show is that length times width. When we do length times width, that's really finding the area. So we can say that our volume is area times our height. And when we do that, we can then fill in our numbers. Volume equals our area times our height. And when we do that math out, 45 times 9, we end up with 405 feet cubed. And we want to make sure that our answer stands out with a unit. Next, we're we're moving on to some more items with pictures. So now, on this one, we have some mistakes in here. We had said this won't work with what we have set up, so we're just going to quickly switch these. So we have different measurements, and we know that every milliliter is equal to 1 cubic centimeter. So the first thing is, it says to find the volume of the prism. That's right here. So we know that volume equals length times width times height. And our length across is 20 centimeters. Our width back right here is 4 centimeters. And our height is 5 centimeters. And as we multiply that out, we end up with 400 centimeters cubed. We talked about circling our final answer. And then it says to shade the liquid. Well, 400 centimeters cubed is the same thing as 400 milliliters. So I can find my 400 milliliters, and I can shade that all in once I've drawn my line to show it. Next, we have 3 different cubes here, rectangular prisms. They're not all cubes. Cubes would be the same on each side. So we're working, and we always want our volume equals length times width times height. So the first thing we're going to do is we're going to find the volume of A. So we'll put VA. It tells us up here in planter A that the length is 13 times 2 times 3. And when we figure that out, the 13 times the 2 times the 3, we get 78 centimeters cubed. That's one answer, and I'm even going to box that. Then I'm going to find for volume B, up in the word problem, it also tells me this information. We have 8 inches by 2 inches by 4 inches. And when we multiply that all out, we end up with 64 inches cubed. Now when I'm looking here, I have 2 answers. I have inches cubed and centimeters cubed, so I have to go back. The unit is inches everywhere, so I need to make sure that I'm not always writing centimeters cubed. Sometimes it's inches cubed. And now we're going to go for the volume of C. And in the volume of C, I'm going to use a different pen to help point things out. We see our length right here for C is 2. We do see our width right here of 2. The question is, what is this height? Well, this whole entire height from here to here is 12. And I see that the height of A was 3 inches, so I'm going to fill that in right there. And the height of B was 4 inches, and I'm going to fill that in right here. So if I have 3 inches and 4 inches, so far I've used 7 inches of my 12. So what's left? This piece has to be 5 inches. And if I wanted to check, I can say 5 plus 4 plus 3, and that equals 12, so it makes sense. So we're going to put that in there. So we've shown our work for all of that, and 2 times 2 times 5 is 20 inches cubed. So we have now found the volume of all 3 rectangular prisms, but the directions ask for the total volume. So now I need to add my 78 and 64 and 20, all of these being inches cubed. And when I add all of those together, I end up with 162 inches cubed. And I'm going to circle that answer as well. Last, a storage shed is a rectangular prism, so we know we're going to be working with length times width times height. And it has a dimension of 7 by 6 by 13, so it's 7 by 6 by 13. And I'm going to draw my picture. And it's going to show that it's 7 meters long by 6 meters by 13 meters. There's my picture showing that. And when I solve my 7 times my 6 times my 13, I get 546 meters cubed. So she's going to double her dimensions. When she doubles her dimensions, I'm going to come over here and do my length times my width times my height. The length is now 14, the width is now 12, and the height is now 26. And if I wanted to, I can draw another picture. I don't have to, I can. And I can show that this is now 14 meters by 12 meters and a height of 26 meters. And when I do that, and I multiply all of that out, I'm going to get 4,368 meters cubed. So now I'm going to go back to the question which asks, she would only double the volume if she were to double the dimensions. Well, this was what her volume became. If she doubles her volume from before and does that times 2, she ends up with, when she doubles 546, she's going to end up with 1,092 meters squared. And I see that these two do not match, so I'm going to say she is incorrect. Doubling the dimensions makes the volume much greater.